So lesson 5 is multiplications of polynomials part 2. So it's looking at multiplying binomials and trinomials, or multiplying binomials, 3 different binomials together. Again, it's a systematic approach. You start with 2, multiply them together, introduce the third. Or if you're talking about a binomial with a trinomial, you're still using the distributive property. So if we are determining a rectangle has a length of 5x plus 2 centimeters and a width that is x squared plus 2x plus 1 centimeters, determine the area by completing each of the following. So area is length times width. The length is 5x plus 2, and the width is x squared plus 2x plus 1. So it's a matter of multiplying those 2 expressions together. If we use the distributive property, it means taking the 5x and multiplying it by everything inside the second bracket, and then taking the positive 2 and doing the same thing. So if I multiply the 5x by everything inside the bracket, what would I get? Plus 2. So if I treat this as a positive 2, when I multiply it by everything inside the brackets, I can remove the brackets completely. If this was a minus, then I would treat this as a negative 2, and I'd multiply everything in and remove the brackets. And then I collect my like terms. So there's nothing else with my 5x cubed, but I have 10x squared and 2x squared. 12x squared. And then I have 5x and 4x. And then 2. This first part says we could use a diagram. So we used the diagrams before. 5x, positive 2. And then an x squared, and add 2x, and a 1. And then what I would do is I would multiply 5x and x squared, I get 5x cubed. 2x and x, or sorry, 2 and x squared, 2x squared. 5x and 2x, 10x squared, then I get a 4x, a 5x, and a 2. Which, if you notice, are the same 6 terms that we got over here. It just arranges it differently. Then when I go to combine everything, I've got my 5x cubed. I can combine my x squareds, combine my x's, and then I have my constant. So either method would work, and you would be fine using either way. So we're going to actually use both methods in class example number 2. So with 2a, if I use the distributive property, I'm going to take x squared, I'm going to multiply it by everything inside the second bracket. So x squared times 2x cubed. 2x to the power of 5. We use our exponent rules. X squared times x. X squared times negative 5. Negative 4 times 2x cubed. Negative 4 times x. And negative 4 times negative 5. So now when I go to collect my like terms, I've got my 2x to the power of 5. Then I have my x cubed and my negative 8x cubed. So I get negative 7x cubed. A negative 5x squared. a negative 4x, and a positive 20. So I still end up with 5 terms in the end. For B, if we were to use a chart, so I could use a chart with A as well. Y and negative 6. And then I have a 2y squared, a negative 3y, and a negative 7. So then when I go to multiply these, 2y squared and y, 2y cubed, 2y squared times negative 6. Negative 3y times y. Negative 3y and negative 6. Negative 7 and y. And negative 6 and negative 7. And then I collect my like terms. So the one thing that maybe you've noticed with the charts make it a lot easier to see where your like terms are because it's all nicely separated. So I have 2y cubed, and then I've got these two terms right here, a negative 12y squared and a negative 3y squared. An 18 and a negative 7. And then my 42. Question number 3 is just time consuming. How do you want to approach question number 3? Do we want to use a chart? Do you want to use distributive property? How do you want to approach it? Okay. Do we want to put the 4 into the first expression, or do we want to save the 4 till after? Okay. So then we're going to multiply A by everything in the second term, and what would I get when I do that? Minus 6A. Then if I take negative 4 and now multiply it by everything in that term, or in that second expression, negative 4 squared, positive 12A, positive 24. And then I'm going to subtract what I get when I multiply the next two expressions together. So 4A times 4A, 4A times 3, negative 3 times 4A, and negative 3 and 3, negative 9. Now what would you want to do?
Collect the like terms.
Collect the like terms, okay? So if I collect the like terms in the first term, or the first factor, what do I get?
Minus 7.
Okay, and then when I collect the like terms in the second expression,
16A squared. Minus 9.
because the two inside terms canceled out, okay? Now I can multiply this, everything in here, by 4. So 4A cubed minus 28A squared plus 24A plus 96. And then with this one here, with this minus, think of it as a negative 1. negative 1, and I get negative 16a squared, multiply by negative 1, and I get a positive 9. Or it's the same as adding the opposite. I add a negative 16a squared and a positive 9. Collect my like terms again. I still have 4a cubed. Negative 28 and negative 16 gives me, and then my 24a and 96 and 9. And again, I'm not sure that we could actually eliminate any of those steps. So I wouldn't be in a hurry to try to eliminate steps. I would just make sure that I'm being systematic in my approach, one step at a time. And if you wanted to do the area model, this model right here, you could do that for this to get you to this point here, and then you have to then multiply everything by 4. Actually, you know what? If I did the area model, I would probably multiply this together first, and I would have the 4a and a negative 16, and then I'd have my 3 going down the side. I would probably approach it from that instead. Okay, we're going to skip and we're going to do class example number 4, and then I'll give you all of the questions at one time. Okay. Consider the rectangular prism that's shown here. Has measurements or dimensions that are x plus 1, x plus 2, and x plus 5. How do I calculate the volume of this shape? Length times width times height. The area of the base, which is length times width times the height of the prism. So in terms of my expressions, I have x plus 1 times x plus 2 times x plus 5. So now we're going to expand it out. So again, going back to that 2 times 3 times 4, I can multiply these two together first and then multiply the answer by x plus 5. Or I can multiply these two together first and multiply by x plus 1. Doesn't matter, pick one. So do I want to multiply the first two together or the last two? Sure. Okay, so we're going to multiply the first two together. So if I multiply x plus 1 times x plus 2, what would I get? Plus? Plus? And then I'm going to multiply that by x plus 5. So what would you suggest to do next? Collect the like terms. And then I'm going to take each of these terms in this trinomial and multiply it with the two terms in the binomial. So x squared times x, x squared times 5, three x times x, three x times 5, 2 times x, and 2 times 5. And then I would collect my like terms. X cubed plus okay. I'm going to show you something with class example 5A, and then we're actually going to talk about the two results. If instead of multiplying the first two together, I multiplied the last two together, this is what I get. So I still have my x minus 3, and then I have 2x squared minus x plus 8x minus 4 plus my like terms.
198, and that's 198. So I'm thinking it should have this page. Because it says 2, 5, and 6.
Then I multiply x by everything inside the 2x squared plus 7x minus 4. So I get 2x cubed plus 7x squared minus 4x. And then I take the negative 3 and multiply it by everything, and I get negative 6x squared minus 21x plus 12. Collect my like terms. I get 7 minus 6, so I get 1x squared. Negative 4 and negative 21 gives me negative 25x plus 12. This is what I want you to comment on. What do you notice about this line compared to that line in the way that the terms are written out?
Oh, the line is in descending order.
They're in descending order. When I multiplied the first two terms together first and then multiplied it by the binomial, so when I do the trinomial times the binomial, my terms end up arranging themselves in descending order, provided that these are also in descending order. But when I go the other way and I do the binomial times the trinomial, my terms end up skipping. So when you have the three terms, you're probably better off multiplying the first two terms first and then multiplying by the binomial. It'll keep your terms, your like terms, are more likely to be grouped together naturally. Now take a look at B and tell me what happens if you multiply B out.
You'll get the same answer.
You're going to get the same answer. Do we need to go through it? No, because I have already kind of previewed that with the 2 times 3 times 4. Right? This is the same as 2 times 3 times 4, whereas this could be the same as 3 times 4 times 2. Still going to get 24 either way. So I'm not even going to do that one. So your questions, 1B, 3B and D, 4C, question number 5 is. Actually, for question 3, let's just do 3B. And then 5.